Welcome to the lecture on solving boundary value problem using Petrov Galerkin method. So this method is similar to Galerkin method. In Galerkin method, the principle is in the weighted residual statement, the weighing function is chosen same as the trial function, whereas Petrov Galerkin method, we can choose any function as a weighing function other than the trial function. Right? So the concept for Petrov Galerkin method is the weighing function is chosen such a way that it is not equal to the trial function. Weighing function is not same as the trial function. Right? So as usual, we have to do the find the weighted residual statement by integrating from 0 to 1, followed by the weighing function and the residual. Dx, right? So we can choose any function. For example, so this II, let us phi 1 of x, it can be 1, and phi 2 of x, it can be x. Or you can choose any linearly independent terms, but you can choose x, phi 1 of x equal to x, and psi 2 of x equal to x square. Or you can choose sin x or cos x. It's up to our choice, but it should not be equal to the trial function, right? Psi 2 of x equal to cos x. Any of this you can choose. Okay. So for our problem, let us choose this trial function, and we know the approximate solution that we have already chosen for this boundary value problem. That is y2 of x is equal to 1 minus x plus c1 into x into 1 minus x plus c2 x square into 1 minus x. Okay, so we can choose the function which are not similar to this. So we have two values. Okay, for I is equal to 1, for I is equal to 1, our value would be 0 to 1, w1 of x, so phi 1 of x, which we have chosen as 1. So 1 into the residual function that we already found, this minus 2 plus 4x minus 4x square into c1 plus 2 minus 6x plus 4x square minus 4x cube into c2 minus 4x plus 3 into dx equal to 0. Okay, equal to 0. Now we can expand this. So now this would become minus 2 plus 2 minus 4 by 3 into c1 plus 2 minus 3 plus 4 by 3 minus 1 minus 2 plus 3 equal to 0. Okay, so if we reduce this further, we should be getting 1.333 c1 plus 0.6666 c2 equal to 1. So this would be our first equation. And now if we solve for I equal to 2, so it would be 0 to 1. The weighing function is x, and again minus 2 plus 4x minus 4x square C1 plus 2 minus 6x plus 4x square minus 4x cube C2 minus 4x plus 3 into dx equal to 0. Okay. If we reduce this further, we should be getting minus 1 plus 4 by 3 minus 1 into C1 plus 1 minus um, 2 plus 1 minus 4 by 5 into C2 minus 4 by 3 plus 3 by 2 equal to 0. So if we reduce this further, we should be getting 0.666 C1 plus 0.8 C2 equal to 0.166. This is the second equation. And if you solve equation 1 and 2, so you can solve for equation 1 and 2. Solve equation 1 and equation 2. Okay, then we should be getting C1 equal to 1.1071 and C2 equal to minus 0.7142. So finally the y2 of x equal to 1 minus x plus 1.1071 x into 1 minus x minus 0.7142 x square into 1 minus x. Okay, so this would be the solution for solving the given boundary value problem using Petrov Galerkin method. So concept is very simple. So in the weighted residual statement, we can choose the function, any function as a weighing function other than the trial functions.